Alright, so I work from home. Was looking for a nice, friendly way of identifying to the rest of the household when I'm busy, when I'm on conference call, or even when I'm trying to record a video like this. Well, this was my solution. I don't know if you can see that. Let me turn off the light, and then we'll try it again. Let me show you how I did that. So, my solution was to get a string of this LED strip. These are red. Let's see if I can zoom in and focus. I just use the built-in adhesive to stick it to the outside of the door jamb, and it goes all the way around the door frame. And you can see they really light up. Down here on the business end of the spectrum, I just soldered and shrink wrapped the connections, which then run underneath the door jamb into the office. Well, to the next step in the connection. Let's have a look. Alright, this is the device itself. It is a little ESP8266. I've just put that in a stay in frame. A little connector on a circuit board I whipped up. Basically all it does is it receives a signal from my home automation server on MQTT protocol, and when it gets that signal it turns on this MOSFET, which completes the ground to the LED strip. This is an NPN MOSFET. Oh, stay in frame. It's an NPN power MOSFET. It's triggered by the 8266, and on the back side here I just have a buck converter so that the 12 volt feed which goes to the LEDs is also split off and reduced to the 3.3 volts that the ESP requires. So pretty straightforward, pretty simple, works like a champ. This is currently how I'm powering the LED strip, and you might say, well, that's certainly overkill. Well, for an LED strip, yes it is. However, I intend to trim these wires off and wire them into bus bars that then go around my office so I can power all my devices without having to use a wall wart for every single one, because yeah, I've got wall warts all over the place in 12 volt adapters and 5.5 volt adapters. The PC power supply does 12, 5, and 3.5, so why not just use one to power all my things? I 3D printed the wall mount bracket from a something I found on Thingiverse, and so far it appears to be working once I get the bus bars all put in place. I'll definitely show that off. So this is the code I use for my busy indicator. Got the basic includes up here at the top. This is where you set the Wi-Fi, SSID, and password, fairly obvious. This is the sensor name, what you're going to call the device. And then I use a thing called over-the-air updates. So I'll show you that a little bit farther down. But this is where I would define the password for the over-the-air update. That allows me to update the firmware on the device without having to unplug it and take it back to a machine with the USB cable. I just push it directly out. Makes it a lot easier to configure and add updates and add functionality. These next 3 rows are where I've configured the MQTT server user password. I define the data pin on the device as pin 3. It's the RX pin. And the reason that I use that pin is because I need to pull it low. So the gate, because it's connected to the gate of the power MOSFET, that gate needs to be pulled low for the MOSFETs not to light. If I use the GPIO indicated on the device, the 0 or the 2, and pull those low, it throws the ESP8266 into a different mode that I don't want. So I've resorted to using the data pin for it. It works just fine. This is next 2 rows here are where I define the options for MQTT, how it's going to communicate. Set power sub is how the device gets its order. So a message is set to set power sub, in my case, home busy sign set power, to tell the device to turn on or off. Once it has completed that, it publishes its status, if it's on or off, to the set power pub MQTT topic. That way, if you're in the interface and you turn a switch off, but the switch is offline, turn it on or off, you toggle the switch, whatever, right? And the switch is offline, the switch will reset itself. If it's off because the machine is offline, and you turn the switch on, it'll go back to off on its own because it does not receive confirmation that the switch received the request. All right, so here's why I set up my my Wi-Fi client set up there. My PubSub client is set up here. This is my setup. Pretty straightforward. Set up the Wi-Fi. Configure the MQTT server. I probably should make a variable for that port and stick it at the top, but I haven't. The next little bit is where it sets up the Arduino over-the-air updates. And we'll spin past that. This bit here, this is the setup Wi-Fi from earlier where it actually connects to the Wi-Fi. This is where it listens to the MQTT topics that I've specified. So, if the stream topic on the set power sub, remember that's the one where it gets its orders, it makes set power the string message, which is either going to be off or on. Now, if it's off, then it, right, if set power is off, if that's the command it received, then it publishes to the set power pub that it is off. It's confirming it's off. And if it's on, here's where it replies and confirms it's on. In the main loop here, of course, if it disconnects, it reconnects. There's my, right, Wi-Fi status is not connected, then go back and set it up. If my, there's my OTA handler. If my set power is off, it'll digital write the data pin, remember pin 3, as low. And if set power is on from the previous function here, right, where we define set power, if it's on, of course, it sends the data pin high. And this last little bit is the MQTT client connection. If it's not connected to the server, it attempts to retry every 5 seconds. Plain and simple. That is how the code works for my Busy Light.